This conference will now be recorded.
Hi, good evening, everyone. Is it audible? Hello? Hello, is it audible? Hello? Hello, can you hear me? Hello? Hello?
This
Like
conference will now be recorded.
we cannot apply this the Docker or Docker Composers to the production environment. So we need to use it about one of the COE engine to apply the configuration. To apply that the containers to the production infrastructure. That is, we have like one of the COE, that is Kubernetes, or we have the Docker Swarm, and as well as Mesosphere. So there are the different COE engines are available, but one of that uh, the good the very good community which we have, and as well as very good features which we have, and as well as comparing with that other the COE engines, and which is on the support point of view. So that is the Kubernetes, and we were starting understanding about the Kubernetes and Kubernetes point of view. So one of the concept which we were trying to understand it, that is architecture of the Kubernetes. So the architecture main, so we were understanding about the master nodes and as well as the worker nodes. So master node, what are the important services that we have, and as well as like on the worker node, what are the main services that we have? The master and the
Hello.
worker node. Hello.
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 Yeah. Yes,
Hello.
I'm
Can you
able.
hear me?
Yeah, I'm able to hear Shravanti. Yeah. So we were trying to understand this two concepts on the master node services and as well as the worker node services. On the master node, main four services which we have, like scheduler, API server, controllers manager, and etcd. And on the worker nodes, like which we are trying to understand main two services like the kubelet and kubeproxy. And what are the container we are using? Container related engine has to be installed. So that's about the master node and the worker node services we are trying to understand. And in the master node point of view, the main once if you apply that any configuration changes using the kubectl, the API server is going to read that all those the configuration information as per about our application requirement, and then it is going to store that in the key value representation in etcd database, and which shares that information to that the worker node, that is through the kubelet, that shares that to the like worker node. And once that has been shared, and any new containers which are required to launch it, the scheduler is going to take care of that particular the node, and the particular container is required to launch it on which node. On the base of the hardware and software configuration point of view, it is going to try to launch the particular container on that one of the node. And who is going to monitor it and who is going to keep on getting the health status of those pods is like controllers manager is one of the services helping on the master node, so that is going to keep on collect that. It collects that's the complete information of the nodes statuses and as well as the pods statuses, that is the container statuses. And in case that like a pods or the nodes are got failed, so it is going to try to launch it about that new pods on the new nodes which are available. So that is a controller manager is going to try to take care of it. And once the pods are deployed on this the worker nodes, the pods like how you are going to access it and how you are going to use it about this the network point of view, like accessing of that the applications which are launched on this the pods point of view, the kube proxy is going to help for that service from the worker node. Yeah, so there are the main services that we are trying to understand on the master and as well as worker node. And as a services point of view, we were the services we didn't discuss. Master components is these are the points we had it in the last class. Now let's talk it about it now the resources of that application. That means resources in sense like so far whatever we discussed, how the COE engine, that is the Kubernetes, is supporting the production features, that is the high availability or scalability features or rolling update features, how the data can be shared between the master node and the worker nodes, and how the pods can be launched on the base of the systems and systems information and hardware resources point of view. So these are all like what are the main services from the Kubernetes, from the architecture we are trying to understand it. But the next point is, so once the Kubernetes have been set up that, and if you like to deploy about our custom application, we need to implement some services, some resources. These are all about our deployment resources. That means if you're going to deploy one application or one container on Kubernetes, so these are all the resources that we will implement it. But what are those resources? So one of the basic resource what do we have is pods. So Kubernetes pods are like the so far in the Docker point of view, we are trying to understand the container, and that container, instead of using the container keyword, we use it about the pods. So the pod is the core component of the Kubernetes, and the collection of one or more containers. That means whatever the the containers we are saying about it, like suppose if we just understand about that WordPress application, WordPress and as well as database. So these two containers we were launching with the Docker Compose options. So if you come to this the Kubernetes point of view, so those two containers, like a database container and as well as our app container, WordPress application container, we can group it and we can launch it as a single pod. That means the pod contains collection of one or more containers, and each pod should focus on one container. However, multiple containers can be added to enhance features of the core container. That means we can so the normally one image, one container we launch it, or one image we can launch to multiple containers. But the point of the pods, when what do we talk it is, the pod is either one container or two or more containers. That is on the basis of this application requirement, we can define it, the either one container or a set of containers as together, and to manage it as a single unit, one pod we can define it. And pod cannot be shared on the multiple hosts. Like even the container we cannot share directly on the two or more hosts. One container we can launch it on one node. Like that, the pod also we can launch it on single node, but the pod, one pod we cannot share it to the multiple nodes. So the pod is belong to the single node. If you just try to understand that the pod definition is, the pod is, it can contain the container, either it can contain one container, or the pod 2, if you just observe that it is a combination of the container with volume. Or pod 3, if you just think about it, two pods with volume. Or here the pod 4, three containers with two volumes. So the pod on the base of about our requirement or application definition point of view, application requirement point of view, we can create a pod. Pod can contain either one container or two or more containers. Suppose Docker Compose, instead of using that the app container and as well as the database container, we can group it and with volumes of those containers and everything as a single pod. That means WordPress complete application which is having the app container and as well as database container, and with the volumes we can group it as a single pod. On this pod you can take it and you can launch it on the multiple nodes as a high availability point of view. So the pod is the main core concept of this the Kubernetes. The pod, it can have this either single container or two or more containers. But how do you identify? So once if it is deployed, that application will come back to that. So how do you identify this the set of the containers which you have in the pods? And pods, some more points if you try to understand that pods point of view. Like here in this diagram, if you just observe that, so we have this Nginx is one container, and this Nginx is running on Debian the distribution. Yeah, this Nginx is one container, and so one more application which is having that fsync, that is a synchronization point of view, which is running on CentOS distribution. So there are the two containers and one volume which is defined. As we are trying to understand, pod can have the two or more containers and with volumes. That is on the basis of the requirement of the application. So here in this example, so this pod contains two containers with one volume. But whenever we try to understand about it, so between these two containers, what are all the common and what are all the isolated? So if you try to understand about it isolated, so this container, like Nginx container, whatever we are trying to understand, this container is isolated one. And the second, like fsync application, which is having that is isolated one. These two are isolated containers. So this Nginx, it is having the process, Nginx process. This process is isolated. Compare with that fsync. Fsync is a different process and Nginx is a different process. But the networks and access point of view, if you observe that, if the pod contains the two containers, those two containers host name is same. But within the container, processes is different. The file system is different. Users who are using about within the container, as we know that the container like root user account, test user account, we were creating about it in our examples. The users or the process or the file system of this container is isolated. So what are those resources are isolated within the pod? If we just think it that the processor or the PID, so the containers are isolated, and the file system of the container is isolated, and user namespace is also isolated. But what are the common things? That means within the pod, if you are launching the two containers, these two containers are going to have some commonly used resources. What are those common resources? So network namespace, that means the network which has been created, that means IP address interface. So that interface is the same for these two containers. And host name is also same for these two containers. And as well as volumes which are defining that volumes is also the same for these two containers. So if you are launching the pod can have the two or more or one or more containers. And in that pod, what all the containers are running that container related, the processes or file system and the users, that is isolated one. But to access about these containers, the host names or the network interfaces or the volumes, that can be common. So we will see the practically how it is going to helpful. So we'll come back to this in the practically to see this networks which are all the common, which are all the like isolated. We'll come back to this in the practical session as well as. So if you just think about it, so we are not going to launch the Docker container directly on the Kubernetes. The first, which image you would like to run it, that image we create as a container, or it can contain the two or more containers with the different containers which are required for that application. We can group it and we can launch it to the Kubernetes as a pod. Yeah, so that's about the part. And the next one more keyword if you'd like to know about it. So this once these pods are available, pods we are going to deploy on the nodes. Nodes are nothing but, as we were trying to understand, worker nodes. Wherever you are deploying that about your application, that node. As we know about it, worker node which contain the kubelet and a kube proxy with the Docker. But in this node, you can deploy the multiple pods. So this is one pod, this is another pod, this is another pod. This pod contains the only single container. This pod contains the container with volume. This pod contains, so 3 containers with 2 volumes. So you are hosting the pods on the nodes. Node is that worker node. A node is a worker machine in Kubernetes and maybe either a virtual machine or the physical machine which you can take it depending on the cluster. Each node is managed by the master. A node can have the multiple pods. Yes, we can deploy the multiple pods on the single node. And the Kubernetes master automatically handles scheduling the pods across the nodes in the cluster. Suppose WordPress application you are hosting and you need to have something for replicas. That means the 4 copies of the application. That means even one copy is got failed, another copy. So instead of launching the containers will be abstracted with the pod. But pod, whenever you are creating that, you can abstract the containers and as well as volumes, everything together, and you can take this pod and you can launch the pod on the worker node. But on the single node, we can launch the multiple pods. And the master's automatic scheduling takes into account the available resources on each node. As we were trying to understand, the scheduler service is going to launch the pods on the basis of the available nodes and nodes related system related resources. Here 2 keywords, the application point of view. One is the nodes and second one is the pods. And the third kind of resource what is available to deploy that application is replication controller or replication set. So we'll come back to the controller and set, but what is the replication if we try to understand that? How do we define the number of pods? Suppose if I deploy that about your application, that application we don't launch it with one single instance. If you launch the single instance, that instance is got failed, then there is no concept of the high availability or the failovers. So what we are expecting is at least 2 copies that is required. That means pod you are launching is nothing but pod, at least that same pod you need to launch it the 2 replicas, the replica 1 and replica 2 or replica 3, 4, 5. On the basis of that, the system load point of view, the system availability point of view, the system resources point of view, we can define that number of replicas of that particular pod. Replica is nothing but number of copies of the same pod. If we define the replicas as 3, so 3 copies of the same pod which will be distributed on the nodes which you have configured in your cluster. Yeah, replication controller ensures that a specified number of pod replicas are running at any one time. That is the number of copies that is defined. How does it work? Yes, if there are too many pods, suppose you have defined the replica set as a replication controller as 3. That means 3 copies we are expecting, 3 copies of the pods on the different nodes. But already 4 are running. 4 are running or nothing but too many pods. Like you have defined 3, but more are running. Then the replication control, then the replication controller terminates the extra pods. That is the 4th one which is running, that will be terminated. And if there are too few, that means you have defined 3 but only 2 are running, then new pod which will be launched. The replication controller starts more pods. Unlike manually created the pods maintained by replication controller are automatically replaced if they fail or deleted or are terminated. In case if you delete the pod or if you terminate the pod, so it is always going to, replication controller is going to keep on verifying about it. So it's required to launch the new pods or not. It's always checking about it. How many you have defined the desired equal to current running pods or not. If it is the more, it is going to delete the more pods, additional pods which are the desired, and if you have the less, then so it is going to add the new pods. Yeah, so there is like a replication of the pods are managing by the replication controller or replication set. But what is this the alternative to why we have the replication controller and replication set? So is, I mean, if you try to understand it, objective is the same. What the objective that we have is the number of copies that we are expecting to have a replicas. But the what is the main difference we have is controller cannot be used for the rolling update. Simple. So replication controller, we cannot use it for rolling update strategy. That means rolling update strategy is what we have is, so in the live environment some pods are running, but you need to apply the new version of the images. Suppose let's take it the WordPress application which is running the one version 2.0. Now you need to update that, that's the WordPress application with the 3.0 version, and 4 pods are running or 20 pods are running. 20 pods are running is nothing but you should not take it to the 3.0 applying this directly on the 20 pods at the same time. We should not apply it, because if all are you are applying at the same time, then the end users are impacted. Then what we are expecting is, so instead of applying the like a 20, then first take it 1.5, then apply that the 5 2.0 version of the pods, delete it, and the 3.0 version of the pods, launch it. Then go for the 5 more, take it. Okay, so that is a 2.0 version of this, the old the 2, I mean the 2.0, delete it, and the 3.0 launch it, that like that. So it has to be updated, that is rolling update until to the 20 applying it. So if this strategy we cannot use it if you are going to define the resource type as a replication controller. So we need to use it replica set. This is the advanced one. So now it is recommended for the deployment strategies for the live environment. Replica set is recommended instead of the replication controller. So replica set is like as a controller, and it is having these additional features for the rolling update strategy point of view. But what is the rolling update? We will talk it. So whenever we have the demonstrations, I'll come back this one later. So some differences if you try to understand it. Yeah, so this the replication controller, we cannot use it for the rolling update, and the replica set is going to helpful for that update strategy. So that is deployment strategy purpose we can use it. But if you are not expecting that the rolling update, then go for that using the replication controller. But in the production environment, we are expecting the replication with the deployment strategy, then we need to use it replica set. So this is the advanced one. As simple as it is, replication controller is older approach, replica set is latest approach. But how it is going to helpful, I'll come back to that. So whenever we are going to implement the resources. Yeah, now we understood so far is the pod you can take it and you can deploy on the nodes. But how many pods that is required to, how we can define is a replica set is going to helpful. Is it required that suppose if you take it the pod and if you deploy on the node, it is going to run into only one pod. Sorry. But if you are expecting that the more number of the pods, then we need to use a replication controller or replication set. So if you just think about it, the how you are defining the set of resources is so first we take it about that the pod which contains about the containers. It can have the containers, 1 or 2 containers, that is on the basis of the application requirement, and you are going to define that the pod with a replication set. So that is replication set you are using about it, how many number of pods that is required to launch it. So the pod contains the containers. So how many pods do you want to launch it? That's by using the replication set we can define it. That means pod to the superset is replication set. But so if you just define that the number of copies, 3 copies or the 4 copies, that's not enough. But whenever we are applying to the production environment, rolling update, we are expecting that. Rolling update is nothing but the old version of the pods required to delete it one by one, and the new version of the pods required to launch it that. And it has to manage the load balancer as well. So load balancer to which a request it has to route it, to which pods it has to route it, which pods it should not route it. So everything we need to control it from the load balancers. So that's we'll come back to the load balancers, how you are going to define. So we have the service option. I'll come back. Service, if you try to understand, service is the entry point of that the pod which you are going to access it, our application. But the point is, so replication set, what it is helping is number of pods. So if you would like to define the container grouped as a pod, and how many pods that is required to define it, to define with the replication set. But replication set, if you'd like to deploy with the rolling update strategy, that is a rolling update and a rollback strategy also. Suppose in case the current image version of the suppose 3.0 you are trying to deploy it, but the 3.0 is got failed, you need to roll back to that the previous version 2.0. That means rolling rollout option and the roll back features if you are expecting about it. Then what is the type of resource that is available from the Kubernetes? That is deployment. So deployment resource you are defining is nothing but what we can define in the deployment is rollout strategy. So the first pod you need to create it. That means which image do you want to run as a container, or what are the images do you want to run as a container? That's first we need to define the pod. Pod is one resource. But how many number of pods that is required, how you are going to define is replication set. So is required that the 3 or 4, how many does do you want to run it to the pods? That is a replication set, we need to use it. But replication is just you can define the number of pods, but we cannot apply the rolling update or rollback strategy. That means you cannot roll back to the failed version of that application to the older version of that application. Then what is the type of resource that is supporting is deployment. Deployment which is having that rollout strategy. That means whenever you are applying the change, how many old version of that the pods that can be deleted, how many new version of the pods that can be launched. That means here what are the options are available is we have the two properties which we need to define: max such, max unavailable. But where do we define all these properties? They're all in YAML files we need to define. That means pods creation or the replication set or deployment, all these resources, how do we implement it? So we are going to use it, the YAML files, that will come back later. But we are trying to understand what are the set of resources which are helping to deploy about your application on the Kubernetes engine as a container. So first you need to implement the pods, and there's a how many number of pods that is required to implement it. We need to use the replication set, and once replication set has been defined, then we need to go for deployment. So deployment is the is the superset which contains about the replication set information and pods information. And if you are defining that the replication set is nothing but replication set is the superset to that the pod. Pod you are defining is nothing but which container does do you want to run it in that particular pod, or which are all the container does do you want to run it with the volumes. That's everything we'll define in the pod. Yeah, so there are the main resources like which are helping. There is a deployment. A deployment is responsible for creating and updating instances of about your application. Yes, updating also it is supporting that. Once you have a running Kubernetes cluster, you can deploy about your containerized application on top of it. To do so, you need to create a Kubernetes deployment configuration. Yeah, so deployment instructs the Kubernetes how to create and update instances of about your application. And yeah, so it is going to manage it about it. So once you have created deployment, the Kubernetes master schedules mention application instances onto individual nodes in the cluster. Yeah, so on the basis of the deployment, so it is going to read that the deployment strategies and as well as the replication set information, which pods and how many pods that is required to launch it. Everything that is going to read it from the deployments information, and once that is understood by the scheduler is going to take care of that, launching those pods on how many nodes that is required as the number of replicas you have defined, and whenever you are applying the change, so it is going to take care of that the rolling update strategies. Yeah, so once application instances are created, a Kubernetes deployment controller continuously monitor those instances. As we were trying to understand that is the controller manager is going to keep on monitoring about our instances. Yeah, so if the node hosting an instance goes down or is deleted, the deployment controller replaces it. Yeah, so there are like the self-healing mechanisms which we can call that. Yeah, so here if you observe that, so in this how many nodes we have is the total 3 nodes, the 4 nodes are available. So this is the master node, and 3 worker nodes are available, and each worker node is to have that its node specific process, that is a kubelet and kubeproxy. And whatever the deployment we have applied on the master, and the master scheduler is going to take care of that pods launching about it on the nodes in the cluster which is defined. Yeah, so that is deployment. So the deployment, if you try to understand, deployment you are defining is nothing but we need to define the rolling out strategy. Then it should contain the replication set, and the replication set should be defined with the number of replicas that is a pod, and the pods information we need to define it. Yeah, this is the kind of the complete set of resources where we can take it about our application and we can deploy this in the Kubernetes. As we were trying to understand, that's one more diagram point of view. Yeah, so once these pods have been deployed in the cluster using deployment options with replicas and rolling update and everything. But finally, so this pod you are launching is nothing but all these pods, 3 different URLs you will be having, and all these URLs finally it should be accessed that as a single entry URL, right? That means as we were trying to understand in our normal architecture also, if you are hosting 2 servers is nothing but 2 servers, these 2 URLs which will be taken and which will be configured at the load balancer level. Load balancer is going to helpful to route to the backend the servers. Like that, the Kubernetes, once the pods have been deployed on the different nodes with this deployment strategy with the replication set and the rollout strategies, but you need to have the access point of all these pods or not. Pod is going to have its own specific IP address, but this IP address, if you use it, you cannot access directly that application. So what you need to do that you need to expose that application which you have hosted or which you have deployed that on the Kubernetes with URL. That means this service URL which will be used to access about that the application which is running on the pods. So this service is going to take care of that. So once if you request this using the service is going to check it that this pod or this pod or this pod which are all running on within the cluster on the different nodes. On the base of the availability, so it is going to use it that pod specific internal IP address and the port numbers it uses, and it tries to access that the particular service. And once service is available, so service returning to that this service, and which is going to return back to the client. Yeah, the next kind of the resource what we are trying to understand is once deployment is done, we need to expose the service. But how do we expose that? That means after deploying application in like a Tomcat cluster or WebFly cluster, so we use it about that the load balancer or proxy servers as entry points to access that application, or external load balancers we have, or in our AWS which we're trying to understand, like auto scaling has been defined, that auto scaling group all the EC2 instances which will be mapped from load balancer. That load balancer URL you can use it with the domain name, or you can use it with direct to the load balancer URL if it is internal. So but you have deployed that application with all these features, and once it is deployed on the Kubernetes, but that is going to have the multiple pods which are running on the multiple nodes. Multiple pods are running is nothing but multiple URLs, But all these URLs, how do we abstract it? So that is the service. A service in the Kubernetes is abstraction, so which defines a logical set of pods and the policy by which to access them. Yes, the pods which are running within the cluster. So all the pods related, the URLs logically we will abstract it and we will define that the one entry point URL for about our application which is hosted on the Kubernetes. So before, if you try to understand that, even on AWS also, EC2 instances URLs are the different, and once EC2 instances are available, all these URLs you are defining from the load balancer. Then the load balancer URL is the entry point. But here in the Kubernetes, deployment is how you are hosting about your application on the Kubernetes. But after deploying that, so how you are going to access this application is service is the load balancer. Yeah, the service in the Kubernetes is an abstraction which defines a logical set of pods and policy by which to access them. Services enable a loose coupling between the dependent pods. So it's service. I mean, the services enable a loose coupling. So it is going to have that. So like one pod is deleted. The pod is deleted is nothing but the pod URL is lost from the service URL. Then new pod is launched. That means new pod URL is required to register with the service. Yeah, so that is loosely coupling with the dependent pods. The set of pods targeted by a service is usually determined by a label selector. What is this label selector? I will explain later. So you are deploying that application and you are defining the service for that application. So all these two is required to target it. The service is required to target to the deployment. But how do we define the service targeting to the deployment? That means application you have deployed, but the application related URL, how you are defining with the service, you need to target by using the label selector. But where do we use it? This label selector will come back. Each pod is having its unique IP address, and those IPs are not exposed outside the cluster without a service. Yes, the services allow about your application to receive traffic. Yeah, the services are the main entry point to receive that about your application related all the request. This is like as a load balancer. Services can be exposed in the different ways by specifying a type in the service specific. And the different ways we can expose the service. What are those? Try to understand the service types. The first one is cluster IP. So whenever you are creating that, any deployment or any kind of the replication set or controller is nothing but what is the default type of the service that is defined is cluster IP. So this is the default one. That means you are deploying that one application without specifying the service is nothing but what is the default service that is going to apply is cluster IP. So it exposes the service on an internal IP. That means so if you use it the cluster IP, the service type, then we cannot use it that pod URL from externally. So we cannot use that the pod explicitly. That means only for internal purpose we can use it the cluster IP. This is a default one. But next level what do we have is, suppose as simple as is, if you just think about it, these diagrams. So once pods have been defined, the pod, each pod is going to have its specific cluster IP. This cluster IP used in this we cannot access it. So this is only for internal purpose. We cannot use it for external. So if you would like to access it, what we can do this is, suppose the user is available here. Suppose user is here who would like to access this. Application which is deployed in this. Okay, let's assume that. So this complete deployment you have deployed on the single node. And the same thing like which has been set up that one more node also. Let's assume that this is one more node which we have here. This is the node 1. And let's assume that this is the node 2. And this node is also having the same deployment which is performed. Deployment replication set. Some pods are running here, some pods are running here on the two different nodes. So whenever you use the cluster IP address is only for internal. So you cannot access it, the user cannot access it. If you define that, once if you deploy that application with the default service type, then the user cannot access about this application. But what is the next level which we have is, the second level of the service type is node port. That means in our Docker containers also, if you observe that -p, if I use it and if I publish that with the host port and container port, then my Docker host related IP address and whatever the host port which we have published, with that IP address port number we can access it, the container service which is running internally within the container. And if I would like to directly access about the container service, then container IP address, container port, I need to use it. Or with the publishing option, that means we can publish the container port to the host OS port. The same kind of here, the node port. Node port exposes the service on the same port of each selected node in the cluster using NAT mechanism. So it uses the NAT mechanism. It makes a service accessible from outside the cluster using node IP address and a node port. Suppose if you define the service type as a node port, then we can use it about it, this node related IP address and with the port, the published, the container port, whatever we have. So with that node IP address and a port which is published, we can use it, the user can access it. So node port, the node IP address and the node port, we can use it that. So here he can use it, that's the only node level with IP address and port number which is published, that's on the port. But what is the type of the service you need to use it for about your deployment, whatever you are deploying to the cluster is, the service type has to be defined as a node port. Node port is node level accessing. The first one is you cannot access it explicitly. Second one is node IP address, node port, we can use it with the service type as node port. But in the node port, what are the limitations that we have is here the two URLs we have as a number of nodes, number of URLs. So instead of using this, so what is the next level of approach which you have is, so we can define one load balancer here, simple one load balancer URL, and which is mapped to this all the nodes which are in the cluster. And user is going to use it, this load balancer URL. So here this is the load balancer. So using this load balancer URL, the user can access about it. But how do you need to deploy about your application and which type of the service we need to use it is, that is load balancer. It creates an external load balancer in the current cloud, but it has to be used in the cloud infrastructure. And the cloud, if you are using the AWS, so and if you define the service type as a load balancer, automatically it is going to create one load balancer with that application load balancer, whatever we have, that is ALB. That means that ALB load balancer URL will be published automatically. You don't need to explicitly configure that also. Then that load balancer URL, you can take it and you can use it to access about that the application which is hosted on the Kubernetes. And one more option, so there's the superset to this one, what do we have is, so instead of using this load balancer, what is the one more option is, suppose if you have this any DNS service, so user can use it, this DNS entry on this DNS entry which is mapped to this load balancer, so which is mapped to this backend the services. So that means if you would like to create it for about your application directly with one domain naming or one domain name for that application purpose, then what is the type of the service type that we can use it is, that is the external name. That means in YAML file, in the YAML file we are going to define it. We have this one service type field. The service type field by default, if you don't define anything, cluster IP address, if you define the node port, then it is going to publish that application to the node level. And if you define this load balancer, then the one load balancer which is going to create it and which can be used for about your application purpose. And if you define that the external name, then it is going to create the domain, but domain name we need to define. With that domain name, automatically that's a domain entry which will be created with the load balancer to access about your application. So it exposes the service using an arbitrary name specified by actional name in the spec by returning a CNAME record about it. Yes, it is going to return that one CNAME record with the name. No proxy use is, so this type requires version 1.7 or higher of the KubeDNS. Yes, the DNS, the version, but where we can find it, the DNS, I'll come back to that. KubeDNS, that is also one of the pod which is running within the Kubernetes. Yeah, so after deploying that application, how do you want to access it? So access options, you don't want to access it. Suppose database, you are launching that. Database, we should not give that explicitly. That is only cluster IP address, internal purpose. But you are publishing one application. Yes, application is required to access it from the external, either through load balancer or through that domain name or through that the node level. On the base of the requirement, we can use it for about your application. Which type of the service that do you want to expose that the particular application to access it. Yeah, so here if you observe that the two applications are available, one is A and second one is B, two different applications, and A is having that its specific service, the service A like 10.10.91, so there's the IP address which is created. And here one more service for the B application is, so which is created the 3 pods on the 2 different nodes, and this completed deployment is defined with one service. So this service URL is the entry point to access about it all the pods within this application deployment. That means cluster can have the multiple applications, and each application is having the number of copies of the pods and with the rolling strategies and the service URLs. Yeah, so that is the points to understand it. One of the important resources from the Kubernetes, like the pod contains the containers and with volumes, and these pods you can run on the worker nodes. So this we can define this like the nodes, but the scheduler is going to take care of that, which pod is required on which node. The second type of resource. Third, like once a pod is defined, single pod we don't deploy it always. We go further the multiple copies, but multiple copies of the pod, how to define is ReplicaSet. That is the number of copies of the current pod we can instruct it to the Kubernetes. And if you define the replication set, but it doesn't support for that like rolling update, but if you'd like to use it, that's rolling update strategy, we need to use it, this replication set on the top of deployment. So the deployment is that the main the resource that contains of the replication set, that contains about the pods information, that contains about the rolling update strategies. Suppose if I define the replication set is nothing but there is a number of copies with the pods, that's all. But we don't have the rolling update. But rolling update strategy also, if you're expecting that, then you need to use it to deployment. You can define that update strategies, and you can define the replication set, and you can define the pods. But once if you deploy that application, how do you access that application? But some of this the deployments you should not use it external purpose. Some of this the applications only for internal purpose. Some of the applications for external purpose. So if you have this kind of, then how do you manage it? The service types. That means service is required to define with the deployment. But what the service contains? Service contain the service types. That means how do you want to publish this application? Do you want to only cluster IP, or do you want to only node level? Do you want to only load balancer, or do you need that any the CNAME record for that particular application, which you can use it in the DNS records. Yeah, so that's about the main types of the resources. They're all the resources which we need to implement it for about our application purpose to deploy it. Scaling, as we were trying to understand that the scaling is like up or down. So if you'd like to up more or if you'd like to down it, so then how do you manage it? Scaling is accomplished by changing the number of replicas in a deployment. And we have the scaling out, and scaling 0 is also possible, and it will terminate all parts of the specified deployment. Suppose a replica set, if you define as a 0, then no pods are going to launch it in the Kubernetes. And if you define that the 4 pods which will be launched in the Kubernetes. Yeah, so here one deployment and one pod, and which is a handles its specific service. And in this example, if you just observe that another deployment which has been scaled to that like how many pods? That the 4 pods. But which pod on which node is required to run it? That the scheduler on the base of the hardware and there's a resource utilization point of it is going to take care of it. Yeah, the running multiple instances of an application. Yeah, so there are like the scale up and scale down features point of view, and rolling update. What we are saying about it is, suppose as we were trying to understand, so whenever you are applying the latest version of that application, old version it should not to delete at the same time. It has to go for the first taking some the percentage of that the pods, removing that, and the new pods launching that. Like that, suppose if you have the 100 and if you define that the 10 as a rolling update strategy, then the 10 new pods has to be launched and the 10 old has to be removed. Like that, it has to repeat it the 10 times for all the 10 pods. That is rolling update. So if you try to understand that's rolling update as some example, so here the first it is launch this the 4 containers, the 4 pods on these 3 nodes. Suppose if you define the rolling update with 1, so once if you define it, the new pod has been launched and the old pod has been deleted. This is the updated one, and which is going to have the new IP address. But the service is going to take care of that, binding this new pod to this service level, and the old pod entry will be deleted. That is rolling update. What it is going to do this is, yes, the first it is perform that one, and here if you just observe that the 2, like that means on this node the old one has been deleted and the new pod has been launched, and it has added to that about your services. Like that, the finally we are expecting about it all together, like that, changing about it to that new versions. Yeah, so this is a rolling update, so which we are expecting that. We'll see this anyway with all these examples on the Kubernetes. Yeah, so that's the kind of the resources point of view to understand about it. What are the main resources that's going to helpful to launch the application on the Kubernetes. So we need to define the pods, and our nodes we need to configure it, then a replication set we need to use it, and then we need to define the deployments, and we need to define that services. And after all together defining that, then we can go for that rolling update strategies, or a scale up features or the scale down features, and as well as like a rollback feature. Rollback is in case the current version of that application which you are trying to deploy it is got failed, we need to roll back to that the previous version which was a stable one. Yeah, so how do we manage it all these the resources on the Kubernetes? Yeah, so that's we are going to come back to this to have the demonstrations one by one. So let's first what do we do this is we go for taking about the machines, virtual machines, we launched about it. So that's the 3 machines we are going to take it. One is which is having the master node, and 2 the worker nodes. And once the master node is launched, then we create a cluster, and after creating a cluster we go for launching about it all together. That's a worker nodes, and how do we join these nodes with the cluster. So with all those the configurations we do that. Yeah, so for this purpose, like so let me go to that GitHub. Yeah, so I have, so that project is not available. Let me push it to the first to the GitHub. Somewhere I kept it, so just 2 minutes. And so this is a directory. Let me try to push into this Docker Hub. Yeah, so this is a complete code. So this which we are going to use it for this. And so here, what is the main script that we're going to talk it? So like to launch the 3 virtual machines with the complete Kubernetes related the packages installation and services starting. So here it has been implemented the shell provisioning. So let me explain about it. That's meanwhile. So here in this location, like in IACC, that is the infrastructure as a code point of view. So the provision scripts are available in that Vagrant kube cluster. So you can find it the Vagrant file. And this file, which is helping to launch the 3 nodes with like options, that is the complete provisioning script. So, but what it has been implemented, if I try to understand it. So yes, we are taking about it Ubuntu system. So which we are launching about the first as a kube 01, and then that is, yes, the host name is also defined the kube 01, and this is the IP address of this system. We are going to use it as a master one, and so which is defined the virtual box with the memories as a 4 GB. The first system which is defined with the 4 GB, the master machine, and core process units are the 2, and it is implemented with the provision scripts as a shell script point of view. So the provision script where it is executing is, if you just observe that this is the inline script. Inline script where it is defined is, so here the script is defined. I'll explain this script what it is doing. So this is the first system which is launching with the Kubernetes related the complete packages and services. Like the second system is also we are launching about it with this IP address and with this memory capacities and core process units, and with this inline script, same script we are exporting. That means on all the systems we are going to set up the same configuration. Like that kube 03 is also going to launch it about with the 2 GB system, so with the inline script. But what the inline script is defined is, this means, so it is going to helpful to install that Docker engine, and we need to install the kubectl. The CTL is the command line interface to perform all the Kubernetes related activities. That's package we need to install it, and as well as kubeadmin. So if you like to create a cluster or manipulating the cluster or joining the nodes, so we need to have this one more utility, that is the kubeadmin. So there are all the services. So there's which I mean, these are like the packages which are available. All these packages we need to go for installing on that host. But to install that, like what we are defining the first is, yes, some echo command. It is just provisioning that, installing the provisioning. And what we are doing that the first is in all the 3 systems. So what are the 3 systems we are defining is, one is kube 01, this is the host name, and with this IP address. This is a second system, this is a host name, and this is the IP address. And third system, this is a third system host name, and this is the IP address. So all these 3 systems entries we are adding into that host file. That means, so whenever I am using about it like the ping kube 03, so whenever I run that ping kube 03, then what is the file it is going to look at is etc host file. It is going to look at that kube 03. Is it defined that any host name or not? So if it is defined that in etc host about this entry with this IP address, then it takes this IP address and it tries to connect it to that system. So we need to have that like an etc host file entry about that each node. That entry related host file is already defined. It is already available here. You can just pull this code and you can try to run it. So here host file is already available. In this host file already defined kube 01 mapping with this IP address, kube 02 which is mapping to that the 11th system, and kube 03 which is on the third system. So these are 3 entries, IP address and with the The host name mapping we have done in the host file. That host file we are copying to that as a first entry. So that host file, the copying about it, about our local file, copying to that on each node etc hosts. That is the first entry. Then the next activity what we need to do this is, if we'd like to install the Kubernetes related packages, the Kubernetes related the repository, we need to add it. But what is the repository? And then repository URL and the GPG keys, even in Docker also we had it the same concept. The same thing, like here you can find it that options like it is trying to download it about some GPG key which is required, and the GPG key will be added to that apt key add. So that means whatever the key which you are trying to download it, that key we are adding as a apt key. So that is the GPG key adding, first section. And the second section what do you have is the repository URL we need to define. That repository URL, so already it is defined in the Kubernetes list file. So if we verify that in the same directory, yeah, so this is a repository URL. So the HTTP apt kubernetes.io and Xenial. So the main, this is the repository URL. This repository URL we are adding to this as a Ubuntu point of view. So we are adding to that etc apt under sources list.d to this file, and this file we are trying to copy that. That means what are the URL file that contain that file we are trying to copy to that sources list directory. So in our if it is the Red Hat system or the CentOS system, if you are using m repositories d is the directory, and here on the Ubuntu system, so to which directory we need to copy is apt sources list. That means any package you are installing, the package is going to refer to the source, where it is the source is located. There we call that the repository, and here we call that source. So the source list, the source related Kubernetes related the URL we are adding over here, and then system update, apt-get update. Then we are installing the some packages which are required for that. That is Docker package. Yes, we are going to run the Docker containers. That package is required on all the nodes. And the kubelet, yes, we are going to use it, the kubelet, the command line utility to deploy about your applications or the services or the pods and everything. We are going to manage it with the kubelet. And kubeadmin, so to create a cluster, or kubelet is kind of the service, so that is a communication point of view. kubectl, whatever I was discussing, this is a command line utility to apply the configuration changes, and kubelet is helping about it, like to share that the deployment information or services information between the nodes. And the kubeadmin, yes, this is the utility we are going to use it to create a cluster or to configure the cluster or to join the nodes with the clusters. That is a clusters management. We use it with this utility. And finally, the CNI and network interface has to be installed some packages. That is Kubernetes CNI. Yeah, so there are the packages so which we can refer like as an installation point of view. So where we can refer about it, all this documentation is kubernetes.io is the official site which is available. And here you can browse it, that's the documentation. And here you can see the setup option. So in the setup option, you can find it, the cloud solution they have given, and as well as on-premises virtual machines. Or Windows also, you can set up this, the Kubernetes. So on-premises, the virtual machines, if you browse it about, yeah, so there's a map source here, which they have given. Yeah, so there's a cloud stack. Okay, let me find it this. So yeah, so Minikube also you can use it. That is a single node point of view, but this is not recommended. This is only for the developer systems who use it. And Yeah, so on AWS infrastructure, if you'd like to install it, so you can use it to this option. Corps is another tool which is available, and somewhere you can find it. Kubernetes. Okay, so install that. So let me find it. Ubuntu, which version you are using, that version wise also you can just browse it. So which is going to lead to that. Yeah, so it has been given independent solutions. So Kubernetes on Ubuntu. Yeah, so you need to refer the lot of documentation here. So the kubeadmin, kubelet, kubectl, there are the three services or the packages that is required to install it. And so if you like to install on the Ubuntu, yeah, so this is a command: apt-get update, apt-get install, and go for yeah. So there's a GPG key adding about it, and then update, and then install about that kubelet, kubeadmin, kubectl, and then some apt-mark, so which are helping. And the CentOS or RHL, how do we use it? So here's some documentation of it, so which they have given. The m install, so there are the packages and enabling that, the kubelet. Yeah, so there's a lot of documentation is available. So that is about our patients and about our the how you are going to browse it that. So but so here the simplified about it, this is a script. If you just refer about that about our script. Yeah, so it is already added about that the specific packages, the GPG key and resources list. Then installing this the packages which are required for that. Then once that has been installed, so we need to remove that some file system which is created temporarily for that. That is a varlib kubelet. So just remove that directory. Then swap, we need to off it. So like so these are there's a prerequisite point of view. So we need to disable the swap. So let's stop it about the swap. So as the swap off. And then finally install about it if you're going to use it any NFS file system, that NFS file system related packages. This is for the volumes purpose it is going to support it. On the basis of the volumes point of view, this volumes requirement, we can install that NFS. Yeah, so there are the packages that is required. So there's adding the GPG key, and first adding to the host files, then the GPG key, then the sources list like repository, adding that, then installing that the packages, then like a swapping off, and if you have those any dependencies for the NFS also installing the packages. Yeah, so this script which is helping launching with the 3 nodes, and these are 3 nodes with that Kubernetes related all the packages and services. Yeah, so if you are using about Red Hat or the some specific the distribution, then you need to find it that particular distribution related the packages which are required, or the repositories information, GPG key information. So here if you just observe that the CentOS or RHL, So this is a repository, so which we can repository file you can add it in M repositories by specifying about it name of this repository as Kubernetes, and this is the URL, and enabling with GPG check and GPG key where it can be downloaded. So this file you can add it to that about our like etc M repositories and Kubernetes.repo. Then set and force as a SE Linux point of view. Then the set like replacing about it the permission within this SE Linux configuration file. Then installing the packages and enabling that the kubelet. Yeah, so that is on the basis of the type of distribution which you are using. You can just browse it that the installation process which is required. But this script, so which is helping on the Ubuntu system, so to launch it about the complete the Kubernetes. Yeah, so that's about this script, and tomorrow we go for that. So launching about it, so with this complete the Kubernetes 3 systems, then installing that the Kubernetes related the cluster and joining that these two nodes as a worker nodes to the master machine. So we try to understand it to those points, and once that's understood, then we'll come back to that to launch the resources. That is pods, how do we launch it, and then the nodes. One by one we'll come back to that. What are the resources which we discussed today? Yeah, so that's about for today. So which we have the concepts. Yes, any queries or the questions?
Hello.
Yeah, yes, hello.
Yeah, sir. Good evening.
Yeah, good
Uh,
evening.
yeah, sir. In Kubernetes, how to set proxy?
How to set proxy?
Huh. Because in our organization, they are using proxy. I getting some challenges to fix that proxy issues. I'm not unable to do that one.
Yeah, the proxy, I mean, you are using about it the service type, or which one are you using about it?
No, sir. They are using like I'm no. For example, I installed Dockers previously. In the Dockers, I write one file like VI, I mean /etc system d system, and I may create one directory docker dot service, and in that
Okay.
httpd.conf file like proxy file. In that I mentioned my proxy IP address, HTTP and
Okay.
HTTPS.
Fine. You are asking about it about your, I mean, that is not the Kubernetes proxy. That is which is defined for about your systems internally, right?
Not system, VirtualBox internally.
Yeah, the virtual box communication point of view. Good. That is not the Kubernetes level proxy. That is suppose the system to access about it through the proxy, the entry they have defined, right? The
Where in etc profile file?
no. What I am asking is so like the internet to access about it to the system. Instead
Oh,
of giving the direct internet, and they have defined the proxy entry, right?
yes, yes.
Yeah, so that is internet access point of view. That is not specific to the Kubernetes, or that is not specific to the like I mean the point. So the point I mean which proxy tool it is configured that as to route it that the proxy
They are using proxy service name is proxy NTLM.
NTLM.
Mm. And
Okay.
one more thing, here you show at the time RHL7 installation Kubedom. So I created that repo file for Kubernetes to install Kubernetes.
Yes. Okay.
So I am when I try install when I run this command like m install kubedem-y,
Hmm.
it
Yeah.
will hit the base URL, but it is not hitting because it is throwing error proxy required.
Yeah.
So
Yes. Okay.
somewhere else I configured before that only in that virtual machine.
Yeah, that means that is not able to access the internet about your system.
Yes, sir.
Yeah, so I mean, have you contacted about your proxy team? So who has set up the proxy configuration?
Yeah, I contact them, but virtual mission getting the internet access. But
Mm-hmm.
in this Kubernetes application, I'm not getting the access. So they are not helping to me. That is
Okay,
not our side issue, like that they are saying.
you are able to ping that Google.
Ping is not allowed, and I am unable to ping Google also.
Then Google also you are not able to access nothing, but that is a system level communication, right?
But in browser, I am in GUI. They given access, GUI
Hmm.
mode.
Hmm.
I'm open Google page and I'm browsing something.
Okay, that is Windows system.
No, Red Hat 7.
Okay, that desktop based system they have given to you.
Yes, yes.
Okay, so in that desktop based systems, you are able to access the internet through the browser, but through
Yeah.
the command line, you are not able to access it.
Yes, sir.
Have you tried to download it any curly using about it? So just check it with the
Ah,
different
yes,
scenarios.
yes. I used that one. Curl
Hmm.
command, using curl command, instead of using that curl command, proxy service name and domain username password with which URL I am getting that repo or anything file, that file,
Hmm.
sorry, that URL, and proxy IP where it is stored destination path. Like that I am using, it is working. But you said that here some GPG keys it will be downloaded, na?
Yeah.
Yeah, it is not possible at that time.
Okay. So have you tried with this through the command line just specifying about the same proxy, what all the arguments you are passing?
Okay.
So just to use it about the command line, about
Okay.
m install and about the package name, and with the passing the proxy settings which you are using about your system.
Okay.
So you are
It
saying
not,
about it.
it is not, it is not working, sir. I tried that one also.
Okay. So then I mean we need to check it that is a proxy level settings itself. But what is the tool they are
For
using about it?
for example, in Dockers, I specified in some Dockers dot service file like that I specified now.
Hmm.
So where we any other option to specify the proxy for Dockers or Kubernetes?
Actually, the I mean the M repositories itself will define it.
Sir, M
But
repository means m dot conf file. We can specify the proxy settings.
yeah, m.conf file. Yes, which
But
we can
that
define.
one also I tried, sir, but it is not working.
Hmm.
I need
Okay.
this help. I need a help from you about this proxy. How to set Dockers and Kubernetes proxy.
Yeah, fine. But I mean, so if it is the Kubernetes related the proxy, which we can do that. But about your system level, I need to check it about it. Which tool you are using as a proxy point of view. Those settings, how it can be replicated in our the configuration files. So I need
Means
to check it out.
which proxy means which proxy tool means? I didn't get
Yeah.
your question.
So if about your networking team, whatever that the proxy tool they are using about it, so that tool, the settings which on the base of the tool point of view, the tool service which is using of it, the configurations will be changed.
Okay.
So those service point of view, the configuration files we need to refer about it.
Okay.
But I mean,
In in Jenkins, that plugin manage Jenkins one option is there, na sir? Proxy server proxy settings.
mm, correct.
In plugins dashboard.
Advanced section, yes.
Advanced section. In Jenkins I configured there. It is working at that time.
Okay, okay,
Like that, I want to set proxy for Dockers and Kubernetes also.
okay.
Because host machine getting internet access, but only applications are not getting the access. So in I want to configure in application only, I think.
Yeah. So which we need to check it. I also need to check it about it. So I'll
Sir, could you
verify it
please
and
help
I'll
me
come
on
back to
this
you.
with me?
Yeah, sure. I
Uh,
will check it. I'll check it that.
Yeah, and one more question and one more doubt, sir, in Jenkins. And today I installed Tomcat web application web server.
Okay.
I downloaded Jenkins.war file. I put it
Okay.
on web apps directory. So
Okay.
can I start Tomcat service, or can I start Java -jar Jenkins.var? Like which one can I use? I mean, which one can I?
If the Jenkins.war file is you have taken and you have just copied to the web apps is nothing but just to restart the Tomcat server. On the Tomcat server IP address port number /Jenkins you can use it.
But I tried that one, but Jenkins page is dashing loading the dashboard is very late, sir. See, half an hour, 40 minutes. It's not loading the dashboard also.
Maybe you will be having that out of memory errors. So check it about it.
Out of memory means total VM have 8 GB memory,
No,
and
no, no, not that memory level. The Tomcat server logs check it about it. Any permission exceptions or any out of memory
no,
errors,
it is
then
not showing any errors, warnings. Everything it is shows info messages.
Mhm.
And one more thing, it is not working like that. I stopped that thing, and again I want to did this thing Java hyphen space hyphen jar and Java dot sorry Jenkins dot where I run that. At
Okay.
that time it is showing Jetty server. Some server is
Yes.
saying already it is using. So I stopped Tomcat service and
Hmm.
again run it. But at that
Hmm.
time also I'm not getting anything.
You are not able to access the browser, even that case
Yes,
also.
yes, I'm unable to access. And after that, what I did, I stopped everything and I removed all files and install as a service, like downloading the repo file. Just I done install Java hyphen y.
Hmm.
At that time also, I'm not getting the dashboard. But service is up and running at that time.
Okay. I mean, Java. What is that? -Java.
Install Jenkins hyphen y.
Oh, Jenkins you have installed as service.
I downloaded a repo file, Jenkins repo file. I downloaded
RPM file.
like
Okay.
yes, wget command. I downloaded that repo, and
Okay.
after getting that repo, and I run this command install Jenkins hyphen y. At that time also, I'm not getting the dash page of Jenkins. It is showing where lib secrets install some password. Na, I
Hmm.
copied that thing and cat it that file and given
Okay.
password. After that, I am not getting anything. Up to there only I am getting
Okay. That is the browser issue. So do
browser
one
issue.
thing. Which browser you are using that, make sure about it. The browser related some pop-ups have been enabled or not.
Sir, I am using Google Chrome and the Internet Explorer. I use it both, but another machines also I am using because
Hmm.
IP address with port number, but I am
Yeah.
unable to do
Yeah. So that
unable
is
to
the
do that.
problem with make sure about it. So we have this one player that is the Flash player. So that is installed in the browser or not. Please check it. So there is
Flash
a
player.
problem.
So
Yeah.
previously it is working. So previously I checked something. At that
No.
time it is coming fast, but they changed OS 6 to 7. After that I
Hmm.
want to install. At that time only I am getting this problem. Previously it is working.
Okay. After installing the 7, it is given the problems.
వాట్ ఐ మీన్స్ నా ఐడియా ఏంటంటే యాక్చువల్లీ ఫస్ట్ నేను టామ్ క్యాట్ లో ట్రై చేశాను వెబ్
Hmm.
జెన్కిన్స్ డాట్ వేర్ పెట్టి ఆఫ్టర్ దట్
Correct.
నేను ఏం ట్రై చేశాను మళ్ళీ జావా హైఫన్ జార్ అని అదొక ఆప్షన్ ట్రై చేశా తర్వాత సర్వీస్
Okay.
గా చేశా ఈ మూడు ఏమన్నా కాన్ఫ్లిక్ట్ అయినాయా ఎక్కడన్నా ఇంటర్నల్ గా ఏదైనా స్టోర్ అవుతాయా
Yeah. So same Jenkins home directory, user same user ఇచ్చేస్తున్నారా?
ఎస్ సార్ రూట్ యూజర్ తోనే చేస్తున్నాను సో
Okay.
వ్యార్లిబ్ జెన్కిన్స్ ఫోల్డర్ ఒకటి క్రియేట్ అవుతుంది కదా అది డిలీట్ చేసేస్తున్నాను
Hmm.
తర్వాత యూజర్ యొక్క హోమ్ డైరెక్టరీ లో డాట్ జెన్కిన్స్ అనేది ఒకటి క్రియేట్ అవుతుంది
అవును.
సో
అవును.
నేను అది
అదే
కూడా ఈ
Jenkins.
రెండు రిమూవ్ చేస్తున్నా నాకు ఈ రెండు
Hmm.
పాత్స్ తెలుసు కాబట్టి తర్వాత ఏం చేస్తున్నా రిమూవ్ జెన్కిన్స్ హైఫన్ వై అని ఇస్తున్నా
Hmm.
బట్
ఓకే
ఇంకా ఎక్కడో ఏదో ఫైల్ ఎక్కడో కాన్ఫిగరేషన్ లో కొలిజన్ అవుతున్నట్టు నాకు డౌట్. ఎందుకంటే ఎంతసేపటికి సర్వీస్ అయితే మంచిగా స్టార్ట్ అవుతుంది, ఎర్రర్స్ ఏం త్రో చేయట్లా. ఎర్రర్స్ త్రో చేస్తే గూగుల్ చేయొచ్చు, ఏం త్రో
ఓకే
చేయకుండానే డాష్ బోర్డ్ లోడ్ అవ్వట్లా ఎంతసేపు అయినా.
అస్సలు యాక్సెస్ చేసుకోవట్లేదు అంటే వన్ ప్రాబ్లమ్ వుడ్ బి దట్ ఈస్ సర్వీస్ ఇట్ సెల్ఫ్ ఈజ్ నాట్ కమింగ్. And if you are able to access that like that is a password page, and after giving the password plugins ఒకటి పాపప్ వస్తుంది, గుర్తుందో లేదో ఆ
ఎస్
పప్పు
సార్, పాపప్ వస్తుంది. ఒకసారి ఏమో అక్కడ దాకా వెళ్ళి ఎండ్ అయిపోయింది, ఒకసారి ఏమో పాస్వర్డ్ వరకు వచ్చి ఎండ్ అయిపోయింది. ఇక ఆ తర్వాత నుంచి ట్రై చేస్తున్నా, అసలు అది కూడా రావట్లా. బట్
ఓకే
సర్వీస్ స్టిల్ రన్నింగ్ అని చూపిస్తుంది. లాగ్స్ చెక్ చేస్తుంటే అసలు లాగ్స్ లో ఏ ఇన్ఫర్మేషన్ లేదు.
ఓకే జెన్కిన్స్ సపరేట్ ప్రాసెస్ లాగ్స్ చెక్ చేశారా, ఏ లాగ్ ఫైల్?
జెన్ సర్వీస్ లాగా ఇన్స్టాల్ చేస్తేనేమో జెన్కిన్స్ లాగ్స్ చెక్ చేశాను సార్. టామ్
వేర్
క్యాట్ లో
లాగ్?
పెట్టేనేమో క్యాట్లీనా డాట్ అవుట్ అండ్ యాక్సెస్ లాగ్స్ రెండు చెక్ చేశా, బట్
ఓకే
నో.
అది మీరు బిఫోర్ స్టార్టింగ్ అబౌట్ ద సర్వీస్ మేక్ షూర్ అబౌట్ ఇట్. డాట్ జెన్కిన్స్ డైరెక్టరీ ఏదైతే ఉంటుందో యూజర్ హోమ్ డైరెక్టరీలో, ఆ డైరెక్టరీ ఒకసారి డిలీట్ చేయండి.
చేశాను సార్. అసలు సర్వీస్ మొత్తం అన్ఇన్స్టాల్ చేసి మొత్తం యూజర్ యొక్క హోమ్ డైరెక్టరీలో డాట్ జెన్కిన్స్ ఫోల్డర్, వేర్ లిబ్ లో జెన్కిన్స్ డైరెక్టరీ రెండు డిలీట్ చేసి చేశాను. కాకపోతే నా దగ్గర ఆప్షన్ ఏంటి లేదంటే వర్చువల్ మెషిన్ ని రీబూట్ చేసే ఆప్షన్ నా దగ్గర లేదు.
ఓకే రీబూట్ ఏం అవసరం లేదు, బట్ మెయిన్ ఒకసారి 8080 సర్వీస్ పోర్ట్ స్టిల్ అప్ అండ్ రన్నింగ్ అవుతుందా లేదా చెక్ చేశారా అన్ని
అవుతుంది
ఇన్స్టాల్
సార్,
చేసిన తర్వాత?
అవుతుంది. అన్ఇన్స్టాల్ చేసి అన్ని చేసినా కూడా నేను అదే PS-EF చేసినప్పుడు పోర్ట్ ఇచ్చిన ఇది సర్వీస్ చూపిస్తుంది.
సర్వీస్ అప్ అండ్ రన్నింగ్ చూపిస్తుందా?
ఎస్ సార్. అంటే
అవునా?
సర్వీస్ అప్ అండ్ రన్నింగ్ చూపించట్లా, సర్వీస్ ఇన్యాక్టివ్ స్టేట్ లోకి వెళ్తుంది. PS-EF పోర్ట్ నెంబర్ చేస్తాను చేస్తారా, అప్పుడు జెన్కిన్స్ వస్తుంది యాక్సెస్ లో ఉన్నట్టు.
ఓకే నెట్ స్టార్ట్ -10 యూజ్ చేయండి. 8080 సర్వీస్ తో ఏమన్నా రన్ అవుతున్నాయా లేదా అది ఈజీగా ఐడెంటిఫై చేయొచ్చు.
వాట్ సార్, ఒకసారి కమాండ్ చెప్పండి. నెట్ స్టార్
-10
ఓకే.
అండ్ గ్రెప్ పోర్ట్ మీద ట్రై చేయండి, 8080 పోర్ట్ మీద. అంటే ఏమైనా
నేను
సర్వీసెస్
గ్రెప్ అలాగే చేశాను సార్. గ్రెప్ చేస్తే టామ్ క్యాట్ లో రన్ చేసినప్పుడేమో టామ్ క్యాట్ నేను ఎక్కడైతే నా టామ్ క్యాట్ హోమ్ డైరెక్టరీ ఉంటుందో ఆ హోమ్ డైరెక్టరీలో రన్ అవుతున్నట్టు చూపిస్తుంది సర్వీస్ మొత్తం.
ఓకే టామ్ క్యాట్ హోమ్ డైరెక్టరీలో సర్వీస్ రన్ అవుతుందా?
అంటే నేను గ్రెప్ చేస్తాను కదా సార్, PS-EF అని పోర్ట్ లో గ్రెప్ చేసినప్పుడు నేను టామ్ క్యాట్ ఎక్కడైతే నా హోమ్ డైరెక్టరీ ఉంటుందో -D టామ్ క్యాట్ సర్వీస్ ఏదో ఒకటి ఆప్షన్ ఉంటుంది సార్, అక్కడ మీరు చెక్ చేసుకోవచ్చు అని చెప్పారు. దాన్ని నేను నోట్ చేసుకొని చెక్ చేశా. అంటే ఇప్పుడు ఫర్ ఎగ్జాంపుల్ నా దానిలో 5 టామ్ క్యాట్స్ రన్ అవుతున్నాయి అనుకోండి, ఆ సర్వీస్ ఏ టామ్ క్యాట్ తో చూడటానికి ఒకటి చెప్పారు మీరు మెయిన్.
అవునవును కరెక్ట్.
అది చెక్ చేశాను సార్. అది చెక్ చేస్తే ఏమవుతుందంటే ఈ జెన్కిన్స్ వేర్ ఏ డైరెక్టరీలో అయితే ఉందో సేమ్ అదే పాత్ చూపిస్తుంది.
ఓకే అంటే అది జెన్కిన్స్ అప్ అండ్ రన్నింగ్ సర్వీస్.
మరి నేను స్టాప్ చేసినా కూడా సర్వీస్ అప్ అండ్ రన్నింగ్ లోనే ఉంటుంది సార్.
అది ఇన్స్టా ఆఫ్
అట్లాగని
పోర్ట్
పేజ్ మాత్రం రావట్లా.
అదే ఇన్స్టా ఆఫ్ పోర్ట్ నెంబర్ యూజ్ చేయకుండా ఒక పని చేయండి. సో సర్వీస్ నేమ్ తో సెర్చ్ చేయండి జెన్కిన్స్.
ఓకే.
PS-AUX ఆప్షన్ కానీ ఆర్ EF ఆప్షన్ కానీ యూజ్ చేసి జెన్కిన్స్ సర్వీస్ జావా ప్రాసెస్ ట్రై చేయండి. జావా ప్రాసెస్ ఎన్ని రన్ అవుతున్నాయి, జెన్కిన్స్ ప్రాసెస్ ఎన్ని రన్ అవుతున్నాయి, ట్రై టు ఫైండ్ ఇట్ అబౌట్ విత్ దట్ ఆప్షన్. అండ్ సో మీరు టామ్ క్యాట్ కనుక వేరే నెసెసిటీ లేదు అండ్ దట్ ఈస్ జస్ట్ వీ హావ్ స్టార్టెడ్ టు లాంచ్ ద జెన్కిన్స్ అనుకుంటే టామ్ క్యాట్ ని కంప్లీట్ గా ప్రాసెడ్ ఏదైనా లిస్ట్ ఇస్తే కిల్ చేసేయండి.
ఓకే సార్.
ప్రాసైడ్ అది టామ్ క్యాట్ వేరే అప్లికేషన్ ఏమి రన్ అవట్లేదు, ఐ కెన్ కిల్ ఇట్ అనుకుంటే కనుక జస్ట్ కిల్ ఇట్ అబౌట్ ద టామ్ క్యాట్ సర్వీస్ కంప్లీట్ గా. ఆ ప్రాసెస్ ఏమి లిస్ట్ చేయకుండా జావా ప్రాసెస్ మీద టామ్ క్యాట్ ప్రాసెస్ మీద మొత్తం వచ్చినాయన్ని కిల్ చేయండి. అంటే ఎనీ అదర్ అప్లికేషన్ రన్ అవ్వకపోతే అది మళ్ళీ ఒకసారి చెక్ చేసుకోండి. అది మళ్ళీ
ఇది
జావా
దీనికోసం వేసాను సార్, ఫ్రెష్ గా వేసింది. ఇది ఎంత ఫ్రెష్ మిషన్ ఏంటంటే నాకు
అయితే
టాస్క్.
జావా ప్రాసెస్ టామ్ క్యాట్ జెన్కిన్స్ ప్రాసెస్ టామ్ క్యాట్ ప్రాసెస్ 3 ప్రాసెస్ ఐడెంటిఫై చేసి అన్నిటిని ఫోర్స్లీ కిల్ చేసేయండి. దెన్ మీరు ఏదైతే లాంచ్ చేయాలనుకుంటున్నారో జావా ఐఫన్ ద జార్ ఆప్షన్ కానీ అదర్ టామ్ క్యాట్ కానీ ఓన్లీ ఆ సర్వీస్ ఒక్కదాన్ని స్టార్ట్ చేసి చూడండి. అండ్ బిఫోర్ ఆఫ్టర్ కిల్లింగ్ అబౌట్ ఇట్ జెన్కిన్స్ హోమ్ డైరెక్టరీ కంప్లీట్ డైరెక్టరీ అంటే అంతకుముందు ఏదైనా ప్లగ్ఇన్స్ ఇన్స్టాల్ చేస్తున్నా ద కాన్ఫ్లిక్ట్ అవుతుంది. సో అది కంప్లీట్ జెన్కిన్స్ హోమ్ డైరెక్టరీ ఆఫ్టర్ కిల్లింగ్ ఆల్ దీస్ ప్రాసెస్ ఒకసారి కిల్ చేసేయండి.
ఓకే సార్, నేను అసలు రిమూవ్ చేసేస్తున్నాను ఆ రెండు.
ఒక్కోసారి మీరు రిమూవ్ చేసినప్పుడు లైక్ బ్యాక్ అండ్ సర్వీస్ ఏదైనా యూజ్ చేసింది అనుకోండి, సపోజ్ మీరు టామ్ క్యాట్ తో ఆల్రెడీ స్టార్ట్ చేశారు బట్ దాన్ని కిల్ చేయలేదు అండ్ యు ఆర్ ట్రైంగ్ టు యూజ్ ఇట్ అబౌట్ దట్ సంథింగ్ ఐ మీన్ సర్వీస్ ఓరియంటెడ్ జెన్కిన్స్ అనుకోండి, అప్పుడు ఏమవుతుందండి మీరు డిలీట్ చేస్తున్నా కానీ కొన్ని ఫైల్స్ డిలీట్ అవ్వవు.
ఓకే సార్.
Process it is going to occupy the some file system and which is మీరు once I mean after removing also automatically those files are available. So అందుకని first killing that all the services, then cleaning up that the complete the home directory కానీ the log file system కానీ అది మీరు ఏదైతే అన్నారో అన్ని డైరెక్టరీని సో try to clean up that. అండ్ ఇవన్నీ కాకుండా సో సింపుల్ గా ఫస్ట్ అప్రోచ్ ఏం చేస్తారంటే ద ఎం ఇన్స్టాల్ సర్వీస్ యూజ్ చేసుకోండి. అదైతే లైక్ విచ్ ఈస్ గోయింగ్ టు హెల్ప్ఫుల్ మోర్ టైమ్స్ ఐ మీన్ ఈజీ వే టు మేనేజ్ ఇట్. సో అది ఫస్ట్ ఏంటంటే ఎం ద ఎరేజ్ ఆర్ రిమూవ్ యూజ్ చేసుకొని కంప్లీట్ గా జెన్కిన్స్ రిమూవ్ చేసేయండి. ఆ రిమూవ్ చేసిన తర్వాత పడ్జ్ అనేది కూడా ఒక కమాండ్ ఉంటుంది, పడ్జ్ కూడా అప్లై చేయండి. కంప్లీట్ గా ఫైల్స్ రిమూవ్ ఏం చేస్తుందంటే ఓన్లీ ప్యాకేజెస్ రిమూవ్ చేస్తుంది కానీ కొన్ని యూజర్ లెవెల్లో ఫైల్స్ డిలీట్ చేయదు. పడ్జ్ కూడా ఆప్షన్ ఉంటుంది, పడ్జ్ కూడా చూడండి.
ఓకే సార్.
పడ్జ్ ఈస్ గోయింగ్ టు డూ దట్ ఆల్ ద రిఫరెన్స్ ఫైల్స్ ఆల్సో విల్ బి డిలీటెడ్.
ఓకే ఓకే సార్.
అప్పుడు మళ్ళీ ఫ్రెష్ ఇన్స్టాలేషన్ చేసి చూడండి అన్ని చేసిన తర్వాత.
ఓకే సార్, షూర్ సార్.
అది మేబీ ప్రాసెస్.
ఈ డైరెక్టరీస్ అన్ని డిలీట్ చేసేసి అసలు మళ్ళీ టామ్ క్యాట్ అను ఈ జెన్కిన్స్ మొత్తం ఒకసారి సిస్టమ్ అంతా రీఫ్రెష్ చేయడానికి నేను ఏమైనా ఆప్షన్ ఉందా లైనెక్స్ లో? రీబూట్ కాకుండా ఒకవేళ ఇప్పుడు రేపోస్ అయితే ఎం క్లీన్ ఆల్ అని అలా చేస్తాం కదా, అలా ఇలా సిస్టమ్ ఏదన్నా రీఫ్రెష్ చేయడానికి మళ్ళీ అలా ఏమన్నా ఆప్షన్ ఉంటుందా?
సిస్టమ్ రిఫ్రెష్ అంటే ఈ ఐ మీన్ టామ్ క్యాట్ మీరు ఇన్స్టాల్ చేసింది ఇవి మీ ఫైల్ సిస్టమ్స్ కాబట్టి మీరు సింపుల్ గా ఆర్ఎం కమాండ్ యూజ్ చేసుకోండి.
అంటే ఆర్ఎం కమాండ్ గా చేసేసినాక రీఫ్రెష్ చేయడానికి సార్ మిషన్ ని, అంటే రీబూట్ చేసే ఆప్షన్ అయితే నా హ్యాండ్స్ లో లేదు, నేను దానికి టికెట్ రేస్ చేయాలి.
ఓకే.
సో అలా రీబూట్ కాకుండా ఒకసారి మళ్ళీ మిషన్ ఫ్రెష్ గా
అవి మనకి యూజర్ లెవెల్లో ఉండవండి. అది ద కంప్లీట్ సిస్టమ్ రీసెట్ ఆప్షన్స్ అవన్నీ ఉన్నాయి కానీ కొన్ని కమాండ్స్, బట్ అది అడ్మినిస్ట్రేషన్ లెవెల్లో రిక్వైర్డ్. మీకు అంటే మీరు చేసిన డైరెక్టరీస్ ని మీరు తీసేయడం బెస్ట్.
అంటే నేనేమనుకుంటున్నా అంటే సార్, ఇప్పుడు మనం ఎంఎన్ ఇన్స్టాల్ సర్వీస్ నేమ్ ఇస్తున్నాం కదా, అలాంటప్పుడు మనకు తెలిసిన రెండు డైరెక్టరీలు ఏంటంటే వేర్లిబ్ జెన్కిన్స్ ఒకటి, యూజర్ హోమ్ డైరెక్టరీలో .జెన్కిన్స్ అనేది. ఇవి కాకుండా ఇంకెక్కడైనా కాన్ఫిగరేషన్ చేంజెస్ జరుగుతుందా బ్యాక్ ఎండ్, అది తెలియదు కదా మనకి.
ఈటీసీ ఫోల్డర్ లో కూడా ఉంటాయండి జెన్కిన్స్.
నేను చెక్ చేశాను సార్, cd/etc జేతో చెక్ చేశాను, మరి నాకైతే ఏం రాలేదు ఫైల్స్, ఓన్లీ జావావే వచ్చినవి.
జావా వచ్చినాయి.
జావానే వచ్చింది కానీ జెన్కిన్స్ కి సంబంధించిన ఏ ఫైల్స్ రాలేదు అసలు.
మామూలుగా మీరు ఐ మీన్ రిమూవ్ కొట్టేస్తే ఆటోమేటిక్గా అన్ని పర్జ్ అయిపోతాయి.
ఓకే సార్, నేను ఈ పర్జ్ కమాండ్ అనేది యూజ్ చేయలేదు ఇవాళ.
అది RPM-QVH అనేది ఉంటుంది ఆప్షన్, RPM-QL ఎల్ అంటే లిస్ట్ అన్నమాట. దానికి సంబంధించిన ఫైల్స్ అన్ని లిస్ట్ చేస్తుంది ఆ ప్యాకేజ్ రిలేటెడ్, ఆ కమాండ్ యూజ్ చేస్తుంది.
బట్ నేను ఆర్పిఎం సర్వీస్ కాదు కదా సార్ ఇన్స్టాల్ చేసింది, రెపోతో కదా.
మీరు ఫైనల్ గా ఇన్స్టాల్ చేసింది ఆర్పిఎంఏ కదా. M install అయినా that is like a backend RPM it is going to install it. That RPM file will be downloaded and which will be installed. You can set it with the
yes sir. Now I understood. Okay sir. Yeah, okay sir. ఒకవేళ ఏమైనా డౌట్స్ ఉంటే రేపు మీకు పింగ్ చేస్తాను సార్.
Okay, sure.
Yeah, thank you sir, thank you so much.
Yeah, no problem.